Hello, Namaste, it's me Mohan Giri. Welcome to my fourth tutorial. In this tutorial I will be talking about numerical solution of the differential equation using Euler's method. Okay, so if you know the theory of Euler's method, then it's simply the first derivative of any function y is supposed to be f of x comma y. That means first derivative is supposed to be the function, and we will have given the initial conditions, and using that initial condition we need to find the root of the solution of the differential equation. This is our differential equation, and the first derivative of this equation is supposed to be f of x comma y. And after that we are supposed to find the solution. Then this is the nth solution. Then the next yn plus 1th solution of that equation is found to be using previous solution plus this yachts is the interval of interval in the independent variable x, and this is of course f dash y dash. This f of x n comma yn is nothing but the derivative at x nth position and y nth position. Okay, so this is our solution. Yes, this is our formula. Yn plus 1 would be equal to yn plus yachts into f of x n comma yn. So first of all we will use initial condition here, that is x naught comma y naught, and then we will get yn here. This would be y naught, and this would be f of x naught comma y naught. Okay, so the first solution y1 can be obtained by using initial boundary condition at y, that is y naught plus h into f of x naught comma y naught. Okay, so this is given, y naught is given and x naught is given. That means these are the boundary conditions, initial boundary conditions, and we will find solution using this initial boundary condition, provided that h is also known. Okay, h is nothing but the interval width xn plus 1th minus xnth is h. So difference of the consecutive x is h. Okay, this is width. Okay, so we will write this solution in our Fortran code. So to write something on the Fortran code, we need to open terminal first. So to open terminal, press Ctrl Alt T, and then this is my terminal, and I'm here on the home page. So I should move to the folder where I want to create that file. So in my tutorial I will be doing my code on the Giri document editor, or simply you can use any type of document editor such as gedit, notepad, Giri, code block, etc. But here in this tutorial okay, I can use document editor as well, gedit document. So first let me move to the desktop. To move that I should press CD and desktop here. Okay, now I am in desktop. So I will create a document file using gedit edit. Okay, and the name of the file will be Euler. So to write something on the Fortran, we need to have .f90 as the extension. Okay, so finally this is my document editor, and as you know, program Euler, and this is the format of the program. So as I previously showed, this is the theory. We need to insert x naught and y naught as our initial condition. We need to define function f of x comma y here, and then define this formula. Okay, so for that I can take one example. Let me take example of this. This is the first derivative of y equals x plus twice y. So this would be my f of x comma y. Okay, so now in the document editor, to define function outside the program, I need to insert real function, and the name of the function is of course f of x and int. So this is my format of the function, and now I define f equals yes, previously, okay, x plus 2y is my function, so x plus 2 into y. Okay, so this is my function. I used x and y in here, so this is not only the function of x but y also. Okay, and I used x and y as real, so real I need to define real variable x and y. Okay, this is the function. Now inside the program we need to give initial condition y naught and x naught. Okay, so write that inside the program. So first of all write implicit none. Okay, and so first print please insert the initial condition of x, that is x naught. So this will print on the screen, and the computer will read the value given by you as x. I used x as real variable because x can be any number, integer, real, anything, so it is better to define this x as real parameter. So this is our initial condition of x. Similarly, please define initial condition of y as well. So please insert the initial condition of y, that is y naught. Okay, so this will display in the computer, and computer need to read the value given by you. So for that you need to insert read. Okay, so we will computer will read that as y variable, so y is real, so define y as real parameter. Okay, so we found finally x and y, found we gave initial value of x and y. Similarly, we also need to insert the interval in x. So for that again same format, computer need to display please insert the width of the x interval, width of the x, that is interval, or value of x. Okay, computer will display this, and for reading that again same format, you need to read x as here. Again x may be any number, so it should be defined as real parameter. Okay, so we gave all the input values, we defined function in here as well. So okay, so this function is right outside the program. To call this function inside the program, in my previous video as well I have explained about it. To call any function which is defined right outside the program, we need to insert real external here to call that function. Okay, okay, so this is f. All right, so we have x, y as well as x also. Now what we need to do is, yes, this is our formula for the next case, and this is our formula for the solution of that. So let us first define yes, and also here is yan, and yan is the total number of interval up to which we are supposed to find the solution. So let us define yan as well. As you know, yan is the integer, so define yan as integer. And okay, so do you have any idea how yan can be found? Well, so we do have many ideas regarding finding yan, but basically what we need to do is we are given to find the solution of that differential equation at any point of x. For instance, this is our solution, and finding a value for the solution at x equals 1. So this is the differential equation, this is the condition, initial condition, and we are asked to find the value of y at x equals 1. So this is I can suppose this x equals 1 as x given, so define x given as well in here, x given as xg. So we can find value of n as n equals previously I said n is integer, so integer is defined by int. Okay, so this is the format of integer, and how many number, the last value of x is xg, and interval is x, and initial value is x. So according to this formula, xn plus 1 minus xn is x, but xn plus 1 minus x initial value of x divided by x would give the number. Okay, so that's why the formula would be x given minus x. Okay, I need to include this within bracket, xg minus x divided minus x divided by x. So this is our formula to find n, but this may always not come in the integer. So to do that, we gonna find the nearest integer. So nearest integer is always found using plus 0.5 over here, because okay, adding 0.5 gives the nearest integer. Only including integer and this formula may not give the nearest integer that we want. So to find the nearest integer, we add 0.5 as our true nearest integer. Okay, okay, so this is our n, value of n. Now to find solution up to all value of n from 1 to n, you know, we use do loop here. So to use do loop, we need to define a parameter called I. Okay, I is simply an integer, so use do here. So I runs from 1 to n, because we want to find solution up to xn. Okay, so I define I as 1 to n, that is I runs from 1 to n. Okay, and into this is the format of our do loop. Okay, inside that I will write this formula and this formula. Okay, so here xn plus 1 will be replaced by x, and again will be replaced by x, and x is of course x. So x equals x plus x. I want to explain this. Okay, so this x is the previous value of x in the in I from 1 to n, and that this x is the next value of x. Okay, this x is obtained by using previous value of x. Okay, for I equals 1, this x would be the x that we give as our initial condition. Okay, so first for I equals 1, x will be the initial condition, and x will be added, and finally the x n would be obtained. Okay, so again for I equals 2, this x would be x1 and this x would be x2. Similarly for I equals 3, this would be x2 and this would be x3. Okay, so this x is always previous x and this one is the next x. So this will happens, and the generalization simply this is xn and this is xn plus 1, where actually this is xi and this is xi plus 1, where I runs from 1 to n. Okay, so this is our x, and as you know, y equals y plus in this formula you can simply see y equals y plus x into f. Okay, so that's our formula. So this is nothing but y plus x into means asterisk and the f of x comma y. Okay, what this means is, see, this is again as xn plus 1 equals xn plus h. This is yn and this is yn plus 1. In this formula, this is the previous x and this is the next x, sorry, y. This is our initial condition of y. At first I equals 1, the y would be exactly initial condition of y, and next y would be calculated. So here this is x0 and y0 for I equals 1. Similarly for I equals 2, this would be x1, this would be y1, this would be y1, and this would be y2. So this formula calculates using previous value of x and previous value of y. Okay, so this is our formula. And if we want to print, if we want to display single answer for the value of x n plus 1 and x y plus 1, then we will print outside the undo. But if we want to see the solution at all point of x, then we will print inside the do loop. Okay, so simply I will show that later. Okay, first of all, let me print this right outside the do loop. So print okay, the value of x and its corresponding y is okay, what we're gonna print, x and y. Okay, so this is our program, and just simple, very simple indeed. So I have printed the answer right outside the outside the do loop. So in this case only one answer will be displayed on the screen, but if I insert this inside the do loop, that is inside here, then this will display all the answers, all the values of y at all the values of x up to 1 to n. Okay, so this is our program. First let me save this and let me run it. Okay, go to the terminal, first compile that. Okay, to compile it we need to write the Fortran. Euler is the name of my file, and yes, this is what this is how we can compile it. To show the answer we need to insert ./a.out, and yes, please insert the initial condition of x, that is x0, as previously I shared. Okay, this is our initial condition. Function is x plus 2y. At x equals 0, y is 0. So initial condition is x also 0, y also 0. But x is, what is x? X is 0.25, and we need to find the value of y at x equals 1. Okay, so sorry, in the terminal initial value of x is 0. Similarly initial value of y is 0, and value of x is 0.25. and yes, sorry, so I gave I missed one. We have not given this yaxz. We defined it, but we have not given that. So to do that, same format again. Please print, please insert the value of x at which y is to be, or y or solution, which solution is to be found. Okay, so this is our this is what computer displays on the screen, and the computer needs to read it. Okay, so to read that we have defined yaxz over here. Okay, yaxz at which solution is to be found, that is yaxz. All right, so this is our program. So save it and open the terminal, compile that again. Okay, so see the output. The initial condition is 0 of x, initial condition of y is 0, and value of x is 0.25, and x given, the value of x at which solution is to be found is 1 according to question. So the okay, at value of x, y is 1.02345 43750. So this is our solution. Okay, because question has asked only simply you can see question has asked only find the solution at x equals 1, and we found solution at x equals 1 to be 1.023433750. okay, but if we want to display all the solutions at all values of x from 1 to n, then on this program we need to print the value right inside the do loop. okay, so if I copy this and paste here, then this is our solution. Let us deactivate this for a minute, and I have inserted print right inside the do loop, and this will show all values of x and all values of y inside the do loop. Okay, due to the print inside the do loop. okay, so sorry, first of all let me save it. okay, notice for your benefit, this document is showing asterisk over here. What this means? This asterisk means the file that you have modified and you have not saved the file yet. So whenever I save it, this asterisk will be disappeared. So asterisk represents the modification or unsaved file or unsaved modification. So let me save this, and this asterisk is removed. okay, now I compile this, writing G Fortran, and see the output. okay, so initial condition is of x is 0, initial condition of y is 0, value of x is 0.25, and the value of x at its solution is to be found is 1. And now yes, this is what I was saying. okay, so okay, here the value of n is 4, and the answer is showing for all the values of x at values of 0.5. okay, the first initial condition was 0, so after adding x on that 0, x is 0.25, so the x became 0.25, and corresponding to 0.25 y value of y is this. okay, and similarly on this value of x, again the value of x is added, so 0.25 plus 0.25 got 0.5. on this particular value of x, solution is found to be 0.21, 875, etc. okay, and so on. So at all values of x to all the values of n, solution is found. So yeah, okay, we have to do accordingly to our question. okay, so this is how we can find Euler's method. And please friend, make sure that we are doing some sort of numerical calculation, and this is never free from the error. So of course this process has some sort of error, and we will discuss about that error in the next time on the next video. So okay, finally I would like to check the answer of this. okay, so okay, our question was this, and what's the answer? So the this is giving the process of doing calculation, and finally yes, this is our answer. okay, so we can see, and we can compare the answer obtained by us. So friend, are you ready to compare the answer? okay, for we have not displayed 0 over here. In case of 0.25, the answer is 6.25 into 10 to the power minus 2, but this is not showing that, so slightly different. Similarly 0.50, 0.17, at particular value of 1, the answer is 1.023433750. so exactly we are not getting the answer, but the answer is very near to the true value, and this is because of some sort of errors. Actually the origin of error is truncation error on this formula, because we have assumed on this formula we have assumed only the first order during Taylor series expansion. So because of that, we can get few error on this method. So the improved version of this method is runs kutta method, and I will be talking about runs kutta method on the next tutorial. So friends, thank you so much for watching this tutorial. Please provide some feedback regarding this video, and if you find some error on what I am speaking, then please you can confront with me on the comment as well as on the mail provided on the description below. So thank you so much. Thank you for watching this video.